Hello, I'm Tsai, and in this part of the tutorial, let me give you an introduction of the confidential computing ideas with Intel SGXs. So usually an example I would use to explain the importance of confidential computing is the cloud. So inside the clouds, there are a lot of data, for example, your voices, your fingerprints, your documents being uploaded and processed. And so all these data could face security threats inside the clouds. For example, you think about these cloud services, they're all software, so they could have software vulnerabilities. They could also be taken over by some of the inter-application techniques, such as buffer overflows or memory corruptions, right? All these are possible. You can also have these system software layers, such as operating system. This operating system also has its own vulnerability that can be taken over by OS level attack techniques. And finally, you also have the hardware layers, including the DRAM, the IO devices. All these things, they could also be taken over by hardware attacks or physical attacks. So if you think about all these different kind of attack factors, it's important that for the user inside the cloud, at least they could have some kind of foundation of the trust so that they can put their application in these trusted environments so that they don't have to worry about being taken over by these security threats. So far, there have been a lot of examples for building hardware features to provide this kind of a root of trust for not only for the clouds but also for other kind of environments. The classic example I will introduce today is Intel Software Guard extensions. This is one of the mainstream off-the-shelf CPU feature for providing the root of trust. But also, if you have been aware of the mobile phone world, there's also ARM trust zones. Recently has introduced the same kind of confidential computing features as Intel SGXs. Also, AMD has its own version of root of trust and confidential computing platform called PSP, and Apple Touch ID is special devices for protecting your fingerprints and those kind of stuff. And there are also recently a lot of research prototypes for trust computings and confidential computings, including RISC-V sanctums and keystones. And so in general, there's pretty much similar ideas or similar products that come from different CPU vendors to provide trusted computing and confidential computing platform. So let's use Intel Software Guard extension, Intel SGXs, as an example of explaining the usage of confidential computings for application. So Intel Software Guard extension is essentially a set of special instructions introduced on Intel CPUs newer than 7 generations. So let's say you have 8 generations or 9 generations with i5, i7s, or E3 CPU, then it's likely you already has these features. So using these special instructions provided by Intel SGXs, an untrusted operating system could interact with Intel CPU to create a special environment inside the application process. This environment, we call it enclave. This enclave will be completely isolated from the untrusted operating system. And inside this enclave, you can load a signed application. This means that the integrity of this application will be completely guaranteed by the Intel CPU. And then the application could load any kind of sensitive data into this enclave environment. These data will be protected from the untrusted operating system. A great thing about Intel SGX is that it has the memory encryption features. So if the untrusted operating system trying to read the memory of the enclave, it will find that all the memory contents of the enclave are encrypted and also signed inside the DRAM. So that means they cannot be stolen, they cannot be corrupted. The key used for encrypting and signing these memory will be only known by the Intel CPU itself. So no one else will be able to take this key and be able to decrypt the DRAM on its own. And so this will guarantee that it actually protects the memory data, memory content from the untrusted operating system, even if untrusted operating system is compromised. This is also prevents a lot of hardware or physical attack factors, such as corporate attack that could let you steal data from the physical level. We can see Intel software guard extensions as a combination of security guarantee provided by the Intel CPUs. It provides guarantee for the program integrity so that the program will not be corrupted or compromised. And it also provides you CPU attestation to make sure the CPU package itself is correct and sound. And also you have memory encryption to make sure during executions all the memory data will not be corrupted and or taken by the untrusted operating system. All these features combined together provided the foundations of confidential computing. So let's get back to the example of the clouds. What is the benefit of using enclave inside the clouds? Using enclave, user could actually protect their private data inside the cloud environments. So the idea is user could actually ask the cloud's machines to create these enclave to process this private data in a confidential computing settings. In these cases, essentially you are creating trusted environments on arbitrary machines. Even if you don't trust the machine itself, you can trust the Intel CPU, and hence you can trust these enclave environment to be completely isolated from all the other security threats. Second, of course, you do as a second level of the security guarantee, the Intel CPU also need to prove the identity of the CPU itself and also the identity of the program. This will make user build up the trust for this confidential computing environment so that they can send the application and the data into the environment for processing. Because this proof is a cryptographic proof so that it cannot be easily compromised or generated by an attackers. So this will guarantees the trust between the user and the enclave environment will be established by trusting the Intel CPU. So in conclusion, you can see Intel SGXs as this all off-the-shelf CPU features that you already get on a lot of Intel CPU that you can use for confidential computings. What Intel SGX give you is this environment called enclave that isolates your trusted program from a majority of system security threats such as operating system attacks or even hardware attack. It also gives you end-to-end memory encryption, so this is really nice. You can actually protect your memories and program states from the attackers so that if you loaded some secret into your enclave, they will not be easily stolen. This also gives you defenses against counterfeited or malicious CPUs that even pretends to be SGXs. Using the cryptographic proof, you would know that you are actually interacting with the real Intel CPUs. So Intel SGX is this combinations of security features that you can use for your confidential computing to help you protect your applications. And this will conclude this part of the tutorial.